In this video, we'll look at the computerized IC engine trainer model AM202, designed and manufactured by Scitech Engineering Private Limited. As you can see, this is our model AM202. On the left hand side, we have the control unit, and on the ground, we have the engine unit. First, let us look at the engine unit. There are two types of engine units. One is the diesel engine and the second one is the petrol engine. In the center is the eddy current dynamometer. The eddy current dynamometer is being used for loading the engine. At a given time, we can load any one of the engines. For calculation of the heat balance and for other parameters, we have individual calorimeters. For the diesel engine, we have a separate calorimeter, and for the petrol engine, there is a separate calorimeter. For calculation of the heat balance and for the cooling of the dynamometers, we have a centrifugal water pump which is connected through the PPR piping to our dynamometer and the calorimeter. For the accuracy of temperature readings, the exhaust gas supply and the calorimeters both are insulated. Now let's come to the control unit. This is the computerized IC engine trainer's control panel. First we will start with the schematic of the unit. As you can see, the process layout. On the left hand side, we have the diesel engine, and on the right hand side, we have the petrol engine, and in the center, we have the dynamometer. These placements are similar on the engine unit. We will start with the rating for the engine. First, we will start with the diesel engine. For the diesel engine, the maximum speed is around 1500 rpm and the maximum torque is around 25 Newton meters. For the petrol engine, the maximum speed is around 2500 rpm and the maximum torque is around 20 Newton meters. Let's come to the control panel. On the left hand side, first is the mains indicator, which directly turns on the control panel. Next to it, on the right, is the mushroom switch for the water pump. This water pump is mounted on the engine's unit to supply water to the engines, dynamometer and calorimeters. Here is the dynamometer controller. The eddy current dynamometer can be directly controlled from here with the help of these keypads. On the left hand side LCD, it indicates the speed in RPM, and on the right hand side LCD, it indicates the torque in Newton meter. There is also a function button which is used to access various functions of the dynamometer controller. On the left hand side, we have the diesel tank, and on the right hand side, we have the petrol tank. Below the schematic process layout, we have two wheels. On the left hand side is the accelerator wheel for the diesel engine, and on the right hand side is the accelerator wheel for the petrol engine. On the back side is the air box for supplying the air to the diesel engine for the calculation of mass of air. And for the petrol unit, individual air velocity sensors are connected. Here we have the petrol tank, which is connected to the level indicator, and below that we have a fuel pipe which is connected to a petrol engine. This level indicator is used for indicating the fuel consumption. On this level indicator, there is also a manual scale, and an electrical capacitance type level sensor is also installed. Here we can see a red shaft guard. Under the shaft guard, there is a cardan shaft. The shaft guard is placed for safety purpose. As of now, we have connected our diesel engine to our eddy current dynamometer through the cardan shaft. As you can see, the control unit and the engine unit is separated. Thus, all the vibrations from the engine unit are not transferred to the control unit, and it avoids any errors in the DAQ module. Another advantage is that we can examine both the engines one at a time. This is very beneficial because the diesel engine parameters can be compared directly with the petrol engine parameters with the common eddy current dynamometer. Calorimeters are different for both diesel engine and petrol engine. This way we can calculate our heat balance and the exhaust calculation with the help of the calorimeters. A Crompton-make centrifugal water pump is used for the cooling purpose of the dynamometer and calorimeter. This avoids damage to the dynamometer and the heat exchanger. The calorimeter is a shell and tube type heat exchanger, and the piping used to connect the heat exchanger is made of polypropylene piping. There the thermal protection is very good. The exhaust is also covered with an insulation so that the heat does not radiate out. This will help us to get the correct temperature readings through our exhaust gas analysis for both petrol and diesel engine. After completing the introduction to our model AM202, let us now start with the installation process.